participants in the Code Gladiators competition, and the organizers. My gratitude to you for this opportunity to participate in this joyous function. Congratulations to every one of you for participating in this event. Professionals like you use software engineering technology to win our country's war over illiteracy, hunger, financial exclusion, healthcare, and corruption. The corporate sector will lean heavily on your firm shoulders to create differentiation and to obtain competitive advantage both in the domestic and in the export markets. Healthcare, education, and defense sectors, and our NGOs look to you to build robust information systems for them. You are, therefore, the hope of our country's quest for a better future in the coming decades. Some of you will become entrepreneurs, create new products and services, and create a large number of well-paying jobs that are urgently needed by our country. Some of you will become academicians and advance the leading edge of knowledge. Some of you will remain in the country and add value to the various sectors of our economy that I mentioned earlier. Of course, some of you will go abroad and add value to your adopted country. No matter where you live and what you do, every one of you will remain a software professional in your métier. Therefore, I want to speak to you today on how you can create beautiful, useful, trouble-free, enduring, and best value for money software systems and become a successful world-class software professional. What do we mean by beauty in your work? You are essentially in the business of implementing an application system of functional processes on a computer system. A small number of you will go and build what is called system software. I won't refer to you specifically, but the principles that I talk about will apply there too. An application system is an ensemble of programs connected in an orderly manner and operating harmoniously to serve a unified purpose. A program is essentially an algorithm expressed in a language that a computer can understand. An algorithm is an unambiguous and a finite set of steps to solve a problem. Algorithms are important tools of mathematicians. Therefore, it is appropriate to discuss the beauty of mathematics when discussing the beauty of an algorithm. Plato was the first person to speak of the beauty of mathematics. Aristotle, Plato's student, honed it by saying that beauty signifies a certain order and certain symmetry in arranging the elements of a mathematical expression. Henry Poincare added harmony as an important component of the beauty of mathematical ideas. For me, perhaps the best example of such beauty is Euler's equation, which says e to the power of I pi equal to minus 1. More about the beauty of Euler's equation another day. What do we mean by beauty in systems? Some experts say that a software system is beautiful if it is a set of small, well-coordinated pieces of code working harmoniously, reliably, efficiently, and securely to achieve an aspirational or a noble goal. A good example of a beautiful software system was the system designed by MIT using a 36K 16-bit word computer to handle moon landing for Neil Armstrong, Buzz Aldrin, and Mike Collins in 1969. Coming to the topic of the beauty of programs, simplicity is a very important attribute of such a beauty. The general belief is that the most beautiful aspect of a program is recursion. Recursion is the ability of a program to call itself as a routine successively until certain conditions are met for this program to stop this successive calling. Having said that, my belief is that a good piece of code should not exceed about 40 to 50 lines and should have a simple objective. It should follow the principles of Edgar Dijkstra's structured programming concept and Donald Knuth's ideas expressed in his seminal 4 volumes on algorithms. Special care must be taken on using the control structure. It should have only data coupling and no control coupling with other programs of the subsystem or with the programs of other subsystems. It should have a very clear set of APIs. If it fails, it should have an orderly exit indicating clearly the cause of the failure. It should be reusable very easily by others with similar objectives. Thanks to advances in technology, saving memory is no more an objective. Even an Apple Watch can have 16 gigabytes of memory. But maximizing functional value to be delivered in minimum time from every line of code in a system still remains an essential objective. This objective also serves the important criterion of ensuring the required response time in online systems. After all, timely response to a user in a web-based program is an essential attribute of the beauty of that program. We know that in every real-time system, the computer system has to respond within the resolution time of the suprasystem of which it is a part. This objective remains essential in the design of IoT systems of today. For example, if a surgeon is using a computer-assisted surgery system, the command from the surgeon must be acted upon by the computer within the resolution time of the real-world system of the surgeon, else the surgical instrument may do serious harm to the patient. Quality is another important aspect of the beauty of a program. Managed software development enhances the quality of programs and productivity in the development process. As early as 1980s, Infosys had classified the algorithms we needed for our commercial work as sequential, concurrent, distributed, and event-driven algorithms. We did not know much about, nor did we need randomized algorithms, genetic algorithms, bioinformatic algorithms, graphic algorithms, parallel algorithms, semi-numeral algorithms, combinatorial algorithms, and other types of algorithms for our work at that point of time. We had produced a body of knowledge on how to write programs for each class of these algorithms, what language and what data structures to use, desirable and avoidable constructs, how to get the best performance, do's and don'ts, tricks to use, and tricks to avoid. We had created a library of reusable code for the frequently needed functions. Let me now come back to the concept of the beauty of a system. Some experts believe that the beauty of a system is about how faithfully the system implements user requirements, how robust and secure it is, how simple it is to use, how widely and ubiquitously the system is used, and how widely the system benefits humanity. From the perspective of a wide usage, Google's search engine, based on Laurie Page and Sergey Brin's page ranking algorithm, is probably the most beautiful system. RSA public key crypto system is another good example of beauty. Back here in India, Aadhaar system is perhaps the most beautiful system designed in India, if I use that definition. Aadhaar is clearly the best example of a system that has brought revolutionary progress in efficient direct benefit transfer, reducing fraud in the use of private and public funds, enabling financial inclusion, and many other benefits to our economy. It is a much needed system for user authentication needed by the large number of applications that will come up in our country in the coming decades and will benefit hundreds of millions of our citizens. As a utilitarian, my criteria for measuring the beauty of a modern information system are utility, scalability, response time for critical online and real-time transactions, security, user interface, interoperability with heterogeneous systems and devices, error recoverability, availability, reliability, maintainability, technology, obsolescence, freedom, and cost. I'll also add layered architecture that supports portability as an element of the beauty of a system, with separate layers for operating systems, databases, communication systems, languages, middleware, browsers, and devices. I would also say that the system should give the best value for money rather than being the lowest cost option. After all, economists say value is what you receive and price is what you pay. So the best buy is one which gives maximum value per unit of your money. It is desirable to use this definition by those of us who design and build current information systems for corporations, governments, and other institutions of the modern day. It is very important to remember that an essential requirement for building such a system is the quality and productivity of the talent involved in the project as definers of user requirement, architects, functional and technical designers, database specialists, communication specialists, performance engineering specialists, programmers, security specialists, testing specialists, installation specialists, documentation specialists, maintenance specialists, and operations specialists. Productivity comes from the power of human mind, discipline of following standardized processes, using tools, and from the reusability of proven architects in the knowledge management system of an institution, or from what is available in the public domain. Quality comes from consistently following the proven methods of process discipline. But quality and productivity are an integral part of disciplined and managed software development and methodology. The first thing I learned as an engineering student almost 60 years ago was that you cannot improve what you cannot measure. Therefore, measuring quality and productivity is extremely important for us to become a nation of world-class software developers. My congratulations to you again on taking part in this competition. You are the future architects of our country's information systems. I am sure you will develop beautiful software systems for India and the world in the years to come. My best wishes for a great future. Thank you very much.